Hey guys, we're finally at a good step, at an important step, let's say. We're going to learn about OOP. And before we get started on how to doing it, we're going to talk about it a bit to understand why we're doing it, what's the benefits, and how were we doing it beforehand. So, OOP means object oriented programming, and we're going to talk about that in a second. Before that, before learning this OOP, we were always working with the computer and trying to figure out how the computer works. We were learning the instructions the computer needed for it to do something for us. And we were doing this inside of a procedural way, which means basically we were going, let's say we were going, one second, get my pen. We are going from top to bottom. So we started, let's say, inside our void main as an example. We started at the first line and we did one line at a time. Each of these instructions are going to be following each other one by one, from top to bottom, one statement at a time. And this allowed us to create something, create some instructions to be able to do a task, such as go to the fridge, open the door, look for, let's say, beer. Do you find beer? If there is, take the beer, open the beer, drink it. If there isn't, you do some other steps, right? And the moment it reaches the bottom, it's basically done. Now, the problem with these procedural, the problem with where we were is this is more we're talking about what the computer should do and all of that. We're giving it instructions. We're thinking more about the technicality of the computer than we're thinking about the design. Now, with OOP, we could kind of come around this. So before we go to OP, let's just finish this one. Eventually, we found out that we could create some functionalities. So one function, and if you were talking about Java, so methods. So function, methods, same thing. So we were talking about some functionalities that would do some action for us. And we would create many of these functions that would do a lot of different stuff, and we would call them inside our code, which made our code a bit more readable. But yet again, it was still flowing in a linear way, and it was mostly helping the computer run correctly. Now, inside OOP, let me erase a little bit. Where's my eraser? Inside OOP, we're not looking, we're still going to do this procedural way. We're still going to give it instructions to the computer. But now we're not thinking more the technicality. We're thinking more of the whole design, how the system should integrate to each other. We don't need to see the specifications. We don't need to see the little details, but we need to understand, we're going to create things that will do their own jobs and they will deal with it. What do I mean by this? Well, let's take an example here. A great example is, let's say we're all going computers and eventually maybe one day we'll build our own computer. And when we build our own computer, we need a couple things, and we've so far understand that. As one example, we need a monitor, right? With the monitor, we could display things. Do we really know how the monitor works or not? Well, we know there's like a power button, there's a few other buttons to do other things, and different models of monitors would do variation of the same thing. Other than that, we'll need to also build our computer. This is the most important part. To build our computer, we'll need a tower, right? Again, towers come in different shapes and size and colors, right? So colors, shapes, size, but they all need to have the base form, which allows us to put a motherboard inside, right? So let's say this is our motherboard. Now the motherboard, I don't know, we're not going to go too much into this instructions, but the motherboard's job, let's say, is to supply power to allow information to pass from one component to the next. Now, for the extra details of the motherboard, it's not so important. The point is, it does what it needs to do. And on the motherboard, we have this thing we call the CPU. So we need to add that as well. The CPU's job is to do all of our task and instructions. The computer's, let's say, processing. It's the part of your brain that does the logic and make things happen, like moving my fingers, right? And again, there's a lot of variations of CPUs. There's a lot of variations of motherboard. And inside that, we need to add some memories. And inside that, we need to add a graphics card maybe. Maybe it's integrated into the motherboard, maybe not. Right? And it keeps on going. And then we need a keyboard so that we could type stuff. Right? I don't know. I'm not a good artist. So this is our keyboard. We have our motherboard. We have the CPU, the graphics card, the memories, etc., the hard drive, right? And all of that goes inside the tower, and all of this is connected by wires, etc., etc. Now, if we were to build this in a programming language, let's say in the normally way we had to do, we have to think about every line of code and all of this. And all of those line of codes, they won't be separated into these sections that we see like here, right? We see sections of CPU, memory, graphics, keyboard, etc. They'll be all jumbled up together in a whole shenanigan, and it's a bit confusing. Did I miss something? Did I add something? And so forth, so on. So this is where OOP comes in. What OOP does, it allows you to create objects. And these objects are basically these components that we see. And every one of them, they will deal with their own internal requirements. Sorry, let's put it a different way. They will do what they need to do to function correctly. And what's even more interesting than all of that is that each one of these components, they could talk to each other without it being a linear fashion, let's say. So the tower could talk to the motherboard, to the screens if need be. Maybe the tower is not the best thing to talk about, but they could all talk to each other. And the same thing goes the other way. So now when we program them, we're not thinking about what should come first, what should come second. We're talking about the whole design. What's required for those objects. And we're separating them further and further. This abstraction allows us for future development. So whenever I need to go look for something related to the motherboard, I will go inside the file of motherboard. Inside that file, I'll see what attributes it has, what actions it could do, and I'll either add more actions, modify them, etc. It will still run without me needing to change everything. In a normal procedural way, well, you have to go see where the issue was or where you needed to change. And when you change that, did it affect anything else? Even if you make it into little sub parts using functions or methods, it's still limited, right? So OOP gives us this kind of power to allow us to create objects that communicate with each other if need be, or that they bind all the information required for that object in one single place. And with this, we're talking more about design, right? With this, we could make our applications much bigger without worrying that one bug will break everything else. So again, it's going to take some time as we learn OOP, as we learn what objects mean for us. But to be honest, don't overthink it. Just look at around you. Right now in the real life, we're already doing this everywhere, right? We have rooms. Inside that room, we have, I don't know, microphones. Inside the microphone, we have whatever it needs for it to function. We have keyboards, everything. Everything is an object. And we try to recreate that inside our programming design. And that's OOP, Object-Oriented Programming. I'll see you guys in the next video.